All right, let's do section 10.2, page 496, exercise 3, which reads, use the definition to find the fifth order Taylor polynomial and the Taylor series for the function at x equals 0. And the function that we have is f of x is equal to 1 over x plus 2. And because we know we're going to be taking a whole bunch of derivatives, I'm going to rewrite that as x plus 2 to the negative 1. So let's remind ourselves what the definition is for a fifth order Taylor polynomial. And I've written the general definition over here, which says that Pn of x is equal to the summation from k equals 0 to n of the kth order derivative evaluated at 0 divided by k factorial times x to the k. Now, because we want the fifth order polynomial, we're going to have n equals 5. And we're going to start off by evaluating the first 5 derivatives because we're going to need that. And then we'll write out the whole polynomial and we'll substitute in what we need. So let's start with our 0th term, which is the 0th order definition. And of course, that is just the function itself, or x plus 2 to the negative 1, and we're going to evaluate that at x equals 0, and we are going to get a half. So now we need to take the first derivative, and when we do that, we bring the exponent down, so it's going to be negative x plus 2, now to the negative 2. We're going to evaluate that at x equals 0. And that's going to give us negative 1 over 2 squared. Take our next derivative here, our second derivative. And again, we're going to take that power and bring it down. So now we're going to have positive 2 times x plus 2, now to the negative 3, evaluated at x is equal to 0. And when we do that, we're going to get 2 over 2 cubed. Let's come down a little bit here. And we're going to take our third derivative. And again, we're going to bring our exponent down. So we're going to have negative 6 times x plus 2, now to the negative 4. Evaluated at x is equal to 0, and that's going to give us negative 6 over 2 to the 4. And now I'm going to take my fourth order derivative, and again I'm going to bring my exponent down, so I'm going to have 24 times x plus 2, now to the negative 5. Again, I'm going to evaluate that at x equals 0, and I am going to end up with 24 over 2 to the 5th. And we have one more derivative to go here. So my fifth order derivative of x is going to be equal to negative 120. I'm going to bring that negative 5 down, multiply it by the 24. I'm going to have x plus 2 to the negative 6. Again, evaluate that at x equals 0. And that's going to give me negative 120 over 2 to the 6th. Now down here, I have written out the fifth order Taylor polynomial. So I've got f0 evaluated at 0 divided by 0 factorial times x to the 0 plus f prime evaluated at 0 over 1 factorial times x times the second derivative evaluated at 0 divided by 2 factorial times x squared plus the third derivative evaluated at 0 divided by 3 factorial times x cubed plus the fourth derivative evaluated at 0 divided by 4 factorial times x to the 4th plus the fifth derivative evaluated at 0 divided by 5 factorial times x to the 5th. So let's substitute in all of the things that we have here. And the 0th derivative evaluated at 0 was 1/2. And of course, 0 factorial is 1. My first derivative evaluated at 1/2 was negative 1 over 2 squared. 1 factorial is 1. I'm going to multiply it by x. My second derivative evaluated at 0 was 2 over 2 cubed. 2 factorial is going to be 2, and I'm going to multiply that times x squared. My third derivative evaluated at 0 is negative 6 over 2 to the 4th divided by 3 factorial, which is 6, times x cubed. My fourth derivative evaluated at x equals 0 was 24 over 2 to the 5th divided by 4 factorial, which is 24. Multiply that by x to the 4th, plus my fifth derivative evaluated at 0, which is negative 120 over 2 to the 6th divided by 5 factorial, which just happens to be 120 times x to the 5th. And I'm going to be able to cancel out a whole bunch of stuff. This 2 will cancel with this, my 6 with my 6, 24 with 24, 120 with 120. So to clean this up a little bit, my fifth order Taylor polynomial is going to be 1/2 minus x over 2 squared plus x squared over 2 cubed minus x cubed over 2 to the 4th plus x to the 4th over 2 to the 5th minus x to the 5th over 2 to the 6th. Now that answers the first part of the question, which is to get our fifth order Taylor polynomial, but we're also supposed to be able to expand this to make the Taylor series. And so I think we can see that there's a pattern evolving here. So my general formula here is going to be pk of x, and that's going to be some series going from n equals 0 to k. And I've got alternating signs here, so I'm going to have a negative 1 to the n. I'm also going to have x to the n. But if we notice, the exponent of that 2 is always 1 higher than n, so that's going to be 2 to the n plus 1, and that's going to be our Taylor series.